This is the video for the extension lesson of Chapter 7, Defining and Working with Fractional Exponents. So far we've learned that if we have x squared times x squared, that really equals x to the fourth power. When you have the same base, you add your exponents together. Similarly, if we have 9 squared times 9 squared, we can rewrite that as 9 to the fourth. So let's look at 9 to the 1/2 power, which looks a little strange, I know. But if we have 9 to the power of a half times 9 to the power of a half, our base is 9. That means I could really rewrite this as 9, and if I add the exponents together. So it'd be 9 to the 1/2 plus 1/2, and a half plus a half is just a whole. So it's 9 to the first power, which equals 9. So what this is really saying is if we have 9 to the 1/2 power and we multiply it by itself, we get 9. Well, we've learned something where we say what number times itself equals a number. In this case, what number times itself equals 9. And hopefully you're thinking to yourself, hey, that's the same thing as a square root. So that really means that 9 to the 1/2 power really equals the square root of 9, which equals 3. Let's look at some powers of a third. And I know on your worksheet it kind of got pretty small, so it might be hard to see. But on your worksheet it says x to the 1/3 times x to the 1/3 times x to the 1/3. Okay, so same thing as before. You have the same base. Okay, it'd really be x to the 1/3 plus 1/3 plus 1/3. If we add those together, that's really the same thing as x to the first. Okay, so here we're asking ourselves what number times itself again gives you the given number. Okay, and that's what we call the cube root. So x to the 1/3 power is the cube root of x. So 125 to the power of a third is really saying the cube root of 125. And what number times itself again gives you 125? Well, that would be 5. So our general rule, and I know this is going to look a little bit crazy, but hopefully when we start doing a couple more examples, it makes a little bit more sense. If we have a fractional exponent, okay, now that number in the denominator is the root. We established over here that it was the cube root because it was 3. Over here, I'm going to move back up for a second. The denominator was 2, so it was the square root. So the number in the denominator of the fraction is the root. And we can actually end up raising it also to the nth power. So we can write it two ways. Okay, and you'll see sometimes we'll do it one way, sometimes we'll do it the other way. Okay, but we can take the nth power, so the numerator, and then take the square root of it. Sorry, take the nth root of it, not always square root in this case. Okay, it could be any number, but we're going to take the nth power and then take the nth root. Or if that number gets way too big to do, we can start with the nth root, and then whatever answer we get there, raise it to the nth power. Okay, and you're like, n's and m's, oh my goodness, what is going on? But let's try an example. Okay, so I just rewrote our general rule, nth power and then the nth root, or nth root, then the nth power. Okay, so we can write 27 to the power of 4/3 in two ways. We can take the fourth power of 27, and then take the cube root of it. Or we can find the cube root of 27 and raise that to the fourth power. And I'm looking at this and I see 27 to the fourth and I'm like, I do not want to do that. Okay, because this way looks a lot easier. Because we can say the cube root of 27, that would be 3. And then 3 to the fourth power, that would be 81. So 27 to the power of 4/3 equals 81. Okay, the root is the denominator, then the raised to the power of the numerator. Let's look at 16 to the 1/2 power. Okay, that's the root, so it's really the square root of 16, and that just equals 4. For the next one, 9 to the 5/2, remember we can write it in two ways. We can say the square root of 9 raised to the 5th power, or we can take the square root of 9 first, and then raise that to the 5th power. And I'm sitting there thinking, I don't want to do 9 to the 5th, so I'm going to do it this way. So square root of 9 is 3, and then 3 to the 5th power, if you multiply it out, you should get 243. The next two, we have some negative exponents, so we're going to apply our negative exponent rule from the last lesson. So 25 to the negative 1/2, I'm going to first start by saying, let's stick that in the denominator with a positive exponent. And that 25 to the 1/2 really means the square root of 25, and that would equal 1/5. 4 to the negative 3/2, I'm going to stick it in the denominator, make it a positive 3/2, which really means 1 over square root of 4. I'm going to raise that to the 3rd power. Okay, so if you're noticing, I usually think the root part is easiest first because that makes your number smaller, and then if you need to multiply it out in a power, it makes it a little bit easier. So I usually take the root first and then the power. So square root of 4 is 2, and then 2 to the 3rd power means our answer is 1/8. Okay, last couple slides. 27 to the power of a 3rd. Okay, that's the root, so it's the cube root of 27, which equals 3. 8 to the negative 1/3 would be 1 over 8 to the 1/3. That's the root, so it's 1 over a cube root of 8, and that equals 1/2. 64 to 4/3, that's the root, that's the power. So the cube root of 64, whatever that is, we're going to raise it to the 4th power. Cube root of 64, that would be 4, because 4 times 4 is 16, 16 times 4 is 64. And if we raise that to the 4th power, we get 256. 125 to the negative 2/3, I'm going to stick it in the denominator first. That's the root. So 1 over the cube root of 125 squared. So the cube root of 125 is 5, and then 5 squared is 25. Okay, last two, couple steps here. 12 to the negative 1/2 times 12 to the 5/2. Same base, we can add our exponents together. Actually, this one ends up being quite nice, because we get 12 to the 4/2, which simplifies to 12 squared, and that just equals 144. And the last one, there's a couple ways you can do this one. Okay, most of us might see this and automatically think we need to multiply across and combine some exponents here. Okay, but I'm looking at this, and I can simplify that part because that's actually a little bit nicer. Because we have the same base, we can subtract our exponents, and 4/3 minus 1/3 is 6 to the 3/3 power. And 6 to the 3/3 power, that's really just 6 to the 1st, which is just 6. And 6 times 6 gives you 36. Okay, so to recap, okay, when you're dealing with fractional exponents, I'd say use the denominator first to do that nth root. Okay, so if it's a 2 would be a square root. If it's a 3, it'd be a cube root. Okay, probably really won't make you go any further than that. Okay, and then whatever power you have in the numerator, you would then raise your number to that power. So the nth root and then the mth power.